In this video, I will go over deriving of natural logarithmic differentiation. So when would you use derivative of natural logarithmic function? You would use the derivative of natural logarithmic function when you have a natural log or an ln. So for example, if you have anything with a y equals ln 2x or y equals ln of x squared plus 1. It just has to have that net ln sign, ln in it. A derivative of natural logarithmic function is not the same as logarithmic differentiation. I did a video on logarithmic differentiation. Yes, it's good with logarithmic differentiation. It is you may need to know the rule of natural logarithmic, but it's not the same thing. Okay. Move on to the next slide. Oops. So let's go over the rules for derivative of natural logarithmic function. So rule one, the derivative of ln of x is just 1 over x, where x has to be greater than 0. The derivative of ln of u, where the u is not x, it's 1 over u, and then it's times it by du dx. This is a typo right here. It's not u prime over u prime, it's actually just u prime over u, where u is greater than 0. And then rule 3 is what do you an example of ln of u where the u is not x, for example, let's say they wanted to find the derivative of ln of 3x plus 1. How do you take the derivative of this? It's not the same thing as rule 1, so it states that it's 1 over u, so our u is the inside parentheses, so it's 3x plus 1. Times the derivative of the inside parentheses. So what is the so du dx is the derivative of 3x plus 1 is 3. So it's going to be, clean this up, it's 3 over 3x plus 1. That's pretty simple. Rule 3, the derivative absolute value of u is just u prime over u. Okay, so let's do some examples to apply these rules. So example 1 says find y prime. So our parentheses is not x, so it's going to be our u is going to be x squared, and then du dx is 2x. So you can say y prime equals, so you put a 1 on the numerator because that's part of the rule, and then whatever your u is and then times it by du dx. That's all it is. So that means it's 1 over u, which is x squared, times du dx, which is 2x. So when you clean that up, that's 2x over x squared. Get rid of this x, so this cancels, this becomes a 1. So your final answer is y prime equals 2 over x. Okay, go ahead and pause and write down so we can move on to example 2. Example 2, we have ln of square root of x plus 4x. So this one's a slightly different. You could put a parentheses here. So our u is square root of x4 minus 4x, right? How do you find du dx? So if you want, how do we, what rules do we use? We're going to use chain rule, right? And power rule. So square root, the square root of 4x, the square root of x4 minus 4x is equivalent to saying parentheses x4 minus 4x raised to the 1/2, right? So we have to apply the power rule and chain rule. So it's going to be 1/2, leave the inside alone. And then my new power is going to be 1/2 minus 1 or 2/2. So that's negative 1/2 times the derivative of, so you're applying the chain rule. So you take the derivative of the inside. So what's the derivative of x4 minus 4x? Well, the derivative of x4 is 4x cubed. The derivative of negative 4x is negative 4. So when you clean that up, it should be 1/2 square root of x4 minus 4x. And then the top is 4x cubed minus 4. On the top, it looks like you could take out a 2. So that's 2. And then this is 2x cubed minus 2. And then on the bottom, it's 2 square root of x4 minus 4x. Get rid of the 2's. So you get 2x cubed minus 2 over square root of x4 minus 4x. Okay, so that is du dx. So the rules, so y prime is 1/u, which is square root of x4 minus 4x, times the derivative of du dx is 2x cubed minus 2 over square root of x4 minus 4x. Okay, so your final answer is going to be 1 times 2x cubed minus 2. I definitely could take out a 2, so that's 2 parentheses x cubed minus 1. And then what happens to the bottom? What is the square root x4 minus 4x times square root of x4 minus 4x? The radical disappears, so you're just left with x4 minus 4x. Okay, so this is y prime. And that's it. Okay, go ahead and copy, or go ahead and pause and copy. We'll do example 3 and 4 on the next video. Okay, I will see you on the next video.